So, just a show of hands, how many of you know quantum? Something like this exists. How many of you are practitioners? अच्छा कोई भी नहीं है चलो ठीक है we'll do it in a much more I won't show any algorithms or other mathematical proofs over here. Okay, but I think before I get into quantum, and the topic that was given to me was how do you build a quantum ready workforce. Before we go into quantum, there's a line you have to cross, and the line is obviously about artificial intelligence. With my new expanded role as a chief AI officer as well of TechM, there are various ways in which we actually look both quantum and AI. But before I even get into quantum, these are some of the things that we have done and we are very proud of in the past. I just wanted to bring this out in front of you so that all of you realize that technology is changing and technology is changing at a very, very fast pace. I think one of the things that we are lacking in India is also skills and also how do we prepare for those skills. I think two things that you see over here, all of you have gone through unholy times of COVID. All of you have gotten about 2 or 3 vaccines depending on what you wanted to do as your own will. I think lot less people know that there was an effort that was being done apart from vaccines, which was building the therapeutic molecule or finding the therapeutic molecule that acts against the virus. Now, therapeutics is different, obviously, because vaccine's effect will wane off in 6 months, 9 months, you have to take another vaccine. Therapeutics is like paracetamol. Once you take it, the body develops an immunity. This was my team. We are very proud to say we've gotten a lot of awards in India that the only IT services to have actually found a therapeutic molecule that attacks the COVID virus and has a patent is us. And that's the first thing that you actually see over there. So we're very, very proud that we actually did something for the humanity. It was a massive, massive effort. 10 days I couldn't go back home because I was actually handling the biohazard in my own hand. And I had to ship it to Bangalore to actually get tested. So there's a lot of, so this was genetic and Gen AI, even before the Gen AI word became popular that you know it now. Finding out molecules, finding how they attack the virus, finding out, what are some of the facets that the body may attack as well, like thrombosis, for example, blood clots, right? That should not occur when you inject this, molecule as well. I won't go into Bharat markup language, but how many of you know that about Project Indus? Any show of hands? There's only one. They are my colleagues. So Project Indus, I think if you've not just searched on Project Indus in Google, we are also the only IT services company to have built a grounds-up large language model in Hindi and 37 plus dialects just to preserve the dialect structure itself. This was a challenge that was given to us by none other than Sam Altman last year when he was here in India, and he said India cannot produce a large language model of its own in under $10 million. Well, we've managed to do it in about $400K, or $400,000. And thank you. And the model is running well. It's available on Hugging Face. You can download it. It's actually done as an open source. You can utilize it the way you want it. It's a foundational model that we actually built in. It's built in not just Hindi, but 37 different ways in which Hindi is spoken. So if I use a terminology saying, last week I saw a film, Hindi में आप बोलते हो, पिछले हफ्ते मैंने एक picture देखी. If there's a Marwadi in the house, he would say, Larla hafte maine ek picture dekhi. Larla as a word doesn't exist into vocabulary and doesn't even exist into subtokens. Not even ChatGPT can counter Larla. So those are some of the things that we are actually doing. Of course, we went in ahead and also my team created the first meta bank in India, which is Union Bank of India. If you go to unionbankofindia.com, you will be able to enter into a metaverse lounge. This was the Me Too metaverse movement as well. Everybody wanted to have a metaverse lounge. But this is also governed by certain rules by the RBI, right? You can do certain bits of transactions and certain things not. 140 million farmers today tend to use an app which is also built by us with the Prime Minister's office or the Principal Scientific Advisor, which is called Atmanirbhar Krishi, which was launched by our Honorable Prime Minister in 2021. This is the only app in the world that also looks at soil health card data. So the problem with India is that farming or farmlands are very small as compared to the West. So you have to be pinpoint accurate in terms of when you talk about a specific land as well, or specific places. All right, shifting off to quantum, I think one of the things that you will hear from quantum, and I won't go into theory, I think one of the things that you should do is, it's a field which is fast approaching. It's a field that is also fast approaching AI. It's also a field that is hitting AI in various ways, and there's a collaboration that is happening between AI and quantum. One of our first forays in quantum world, way before any company did security, was in 2018, when we actually did a 200-kilometer line in UK with our partners, British Telecom, and some of the partners over there. And we sent a video over that wire of 200 kilometers, which could not be, during that time, encrypted or decrypted using any technique in this universe. This technique is called quantum key distribution. Why do we look at quantum key as security? I'm going to ask a question. What is the best secure measure that you've used in your enterprises? What's the best security that you use? 256, somebody said? Kaun bola bhaiya? AES 256? AES 256? Any other security level that you know? No, AES 256 gets broken there. Very easily. So if you think you're secure, you're not. And that's the change that we want to bring, and that's the kind of knowledge that we want to give to various communities across the world. Look, there are certain principles of AES 256. There is an RSA that you use. Every time you get into a VPN, you use an RSA mechanism. The RSA system itself is built on something very simple. Prime factor division. Take two big prime numbers, divide them. The resulting is a key. These two are public keys. The one is a private key. Very simple. It's a very simple mathematics. But the key size of the RSA is about 2048 bits. In order to break 2048 bits by your own computer, which you sit with in your lap, which we also call as a laptop, will take 4 quadrillion years. 4 quadrillion years is 1.5 times the life of the universe. So you're secure. Take the best supercomputers in this world, which is Frontier in US, it'll take about 40 million years to break it. You're still secure. A synthetic scenario of a quantum computer breaks it in 100 seconds. So if WhatsApp gives you a message and says, "Bhai sahab, aapke sare message secure hain," please think again. Right? Because that security is vulnerable at a certain point. And that is where we actually get in with quantum security. So this mechanism that we are trying to put in will actually make sure in certain ways that your keys are secure, because keys are the biggest facet of threat. If somebody gets the key, somebody can break into any system in terms of what you're doing. So that's one part that we did. Of course, we extended this. One of the other facet or area where quantum computing is doing. So just to give you the basics, quantum computing is about computing with nature. Computing that involves subatomic particles like atoms, like electrons, making sure that we use them as bits. Bits that you use in your own computer, which is 0 or 1. So when your computer does a flip-flop of 0 and 1, it's basically 0 volt and 5 volt. That's exactly what we're doing. There is slight changes that we do. There's a lot of change. There's a lot of unintuitiveness that comes in when you actually do this. The second case that we did over here is we founded the molecule, but is there a way that we can do it faster? And can we create protein structures faster? Your body itself is a combination of a lot of proteins. If we can make proteins and we can construct proteins, we can also construct drugs. And if we can construct drugs, God forbid anything like a COVID attacks again, these drugs will come faster in the market. And we will have better ways to simulate them and attack in terms of what we're doing. So this is one of the other things that we are actually doing. I told you I won't show any more formulas or algorithms. This is one. It's a min-max system of GANs, but let's leave it. But this is a system that actually creates small molecules. And a quantum system, a quantum machine learning system that creates small molecules and gives us the ability to create small medicinal drugs to attack very, very smaller number of diseases. We are not at the point that we can actually cure a bigger disease like a cancer or whatever, but that effort is significantly on in terms of what we are trying to do on quantum as well. Is AI sustainable today? What's the question? Is AI sustainable? AI is the most unsustainable format of technology that you use today. It is good, it solves a lot of problems, but it is unsustainable. And the reason for its unsustainability is because of the compute that you use and the carbon you spew out. One ChatGPT program that was written and is actually trained uses the energy equivalent to the entire annual energy consumption of about 2,500 American households. So you can imagine that if I have to do this kind of a principle again and again with AI, we are using a lot of energy, we are spewing out a lot of carbon. What do we do? How do we make AI much more sustainable, right? So the way that you make AI more sustainable is through a quantum-inspired technique that is called tensor networks. For those of you who are inclined towards technology, go out and read out about what tensor networks are doing. Tensor networks are essentially trying to crunch the large neural networks that are used in deep learning today, and they're trying to reduce their size. So if they reduce the size without losing a lot of precision and accuracy, if they're trying to reduce the size of the neural network, they're trying to use less compute and less power, and they're trying to spew less amount of carbon as well in the system. There's a lot of work that we are doing on tensor networks. In fact, Project Indus went through a tensor network story as well, where we try and crunch the lot of networks or neural networks that you're doing. Look, this is reality. This is actually going to come you and hit you right away. John Deere team, which was here, which, you asked them a question, how much money is needed? Well, they said one is, of course, the device that was needed. The other is the compute that these guys had to spend on in order to make that kind of a system. And the system that they showed was also a rate-traced RTX system. And that rate-traced system would have used some GPUs for them to actually construct it. They've used energy. They've expended energy. How do we reduce that amount of energy? And that's the way where we are actually using these tensor networks as well. Okay, so I think what we do, and the topic was how do we make people quantum ready. I think one of the first things that you should do, and I think you can take it back to your teams, if your leaders and if your teams want to get in, I think a very important structure is knowledge of quantum mechanics and linear algebra. And linear algebra really means is matrix multiplication, vector, and so on and so forth. What you've studied in 10th standard maths, that 10th standard maths has to come in now, and you have to get in if people want to get in into a workforce of quantum. Computer science and physics is known. You should know coding for quantum as well. There are a lot of accelerators available like IBM's Qiskit, like AWS Bracket, like Azure Quantum, and so on and so forth. You can use one of them, or you can use ask your team to use it. They'll be hands-on with this. Basically takes on a Python code, which most of your developers would be using at this point in time. They should be able to get into the Python system as well. I think for us to be future ready for quantum, we need a lot of upskilling program. I know Achita is here. He does a lot of this work as well with NASSCOM. There's a lot of other activities being done across India to make sure that people are quantum skilled and quantum ready, so that at least you know the basics. And in fact, I can tell you in my lab, there's a 17-year-old girl that has actually written a quantum book. It's called Quantum for Teens. You can search it out on Amazon. It's an easier way for people to understand and get into quantum technology, to understand what are the intricacies, what are the non-intuitiveness of quantum. She's tried to explain it with her own art and design. She's an art student, by the way, she's not a science student. So an art student, if she can actually bring in a quantum world in a piece of book for you to read, then most of us can actually read about it and look at it, right? Of course, certifications, hands-on labs, and simulations are known. But I think a lot of this work is being done by the Indian government as well. We are now, I don't know how many of you know, but 2025 is going to be the quantum year internationally. And the government is spending a lot of effort to actually explain to a lot of Indian workforce and IT that this is a technology, this is just knocking on your doorstep. You just have to embrace that tech and don't get perturbed by this tech. This tech is difficult, it's not easy, but then there are ways in which we can simplify it. Of course, for an equal world, right? How do we rise for an equal world? Of course, one is sustainable AI that I told you. Public-private partnership is very, very important. And there is a lot of public-private partnership. The National Quantum Mission has been set up in India. And the National Quantum Mission has companies like HCL, like Tech Mahindra, like Infosys, and many other IT services providers. But also core startups who are actually building a lot of stuff on quantum. Reach out or just open up your search window and look at quantum, and you will find out that there are hundreds and thousands of companies now that are trying to either get inspired from quantum or using quantum computing as a technique where they're actually putting up a lot of these products, right? I think India has improved over a period of time, but research sponsorships have to improve as well if quantum has to apply in certain cases. And also engaging in open source. Sometimes we take, and India largely has been a consumer of technology. It is now that we are trying to become the producers of technology as well. And for that production of technology, we need to actively engage in open source. There's a battery of effort that is going on across the world. All of you should be engaged in some way or the other, right? 30,000 feet, 5,000 feet, 4,000 feet, hardly matters. And then you need a corporate approach. The approach has to be simple. The approach is, it has to be top-down funding. It's not an easy tech. It has to require a little bit of money when it pours out from top. It has to be innovation-led, of course, but it has to be thought about as an infrastructure play. if you do not have a quantum infrastructure ready, and that is what India is doing, right? India is building its own quantum computer, by the way, right? CDAC is building it. There are other players who are actually building as well in terms of what we're doing. And then you have to decide your area. Tech Mahindra has chosen an area. Tech Mahindra thinks that we are in optimization and machine learning. If we can improve that using quantum, we're good along with security. But there are other techniques in quantum as well. You can look at control and sensing. So tomorrow when an earthquake comes in any part of this world, quantum sensors would be able to tell you about 50% better and faster and earlier that an earthquake may rise. And those are quantum sensors that are being used. There are different sensors that are now being used across the world in terms of doing it. And they're all quantum defined as well. Okay, so again, I told you I won't go into all of these techniques. These are quantum circuits, but these are the list of algorithms that we typically use. It's simple. It's not a big list like AI, but it's also cumbersome because these algorithms are non-intuitive. Right? So if you go back to your teams, they can learn a little bit about these algorithms. They will get skilled and get aligned in terms of what we are talking about on quantum as well. But I end here. India is rising in two facets today. One is AI. We think that we would be the producers of AI technology. And that's a large body of effort being done in terms of large language models, in terms of what we do on AI. We're the bedrock of a lot of AI things. But India also thinks that we've got a role to play in quantum. And when these two would combine together, India has a very, very secure technological future that we think. Thank you so much.